Hello participants, a very good afternoon to all of you. Thank you for joining for this first live session of our NPTEL course, Kinematics of Mechanisms and Machines. To begin with, let me first say that I hope that you are able to go through this course smoothly, are able to follow the lectures, and you are able to do the assignments and submit them in time. In case you have any difficulties, the forum is always open. Please write to us on the forum. So the objective of these live sessions will be to discuss your general difficulties with the course, or if you have some specific doubts, then we can take up, or we will put it also in the forum. If the doubt is generic, then we'll put it also in the forum. So you should be giving us your comments on the YouTube channel. Please use the chat box and give me your comments. Let me start by reviewing what all have been covered. So we are, I think, into the 4th week now. So in the first week, in the first lecture, we discussed about why this course is important, what is the motivation, what are the things we look into in such a course. And we also discussed about what we are going to study, why should we study, and what is the limitation. For example, this is a course on kinematics. So you understand we are going to discuss about motion. And I tried to motivate you with various examples of applications of mechanisms in various domains like posture transfer devices, or the surgeon's tools, or the landing gear of an aircraft, or the aircraft flight simulator. So various kinds of examples were shown to you where the concepts from kinematics or kinematic analysis is very important, and I also discussed what issues are important in which cases. Then in the second lecture, we had an overview of nomenclature that we use in this course, a nomenclature and classification of kinematic pairs, links, chains, etc. So this was covered in lecture 2. Then we discussed about kinematic diagrams, how we draw the bare minimum link combinations and their connectivities in a kinematic diagram. So whenever you see a mechanism, a real world mechanism or machine, you should be able to find out, or you should be able to draw or understand how the kinematics is working. So for that, we require the kinematic diagram. It's a very important part of first step for analysis, because we have to identify chains, we have to identify various links that are there, the kind of kinematic pairs that are being used. So these things make up the kinematic diagram. Of course, in a kinematic diagram, we do not worry about the dimensions. Then we discussed about the degree of freedom of kinematic chain, how to calculate degrees of freedom in planar case, in spatial case, and we took various examples. And then we looked at the so in the spatial case, we looked at robotic devices, and we calculated the degrees of freedom of robotic chains. In the second week, we started off with the failure conditions for this degree of freedom calculation. You have to remember that this degree of freedom calculation gives you a generic degree of freedom. It does not work when the dimensions are special, or you have a 3P loop, for example. If you have redundant links, then this degree of freedom calculation fails. And we have looked at various examples, and we have tried to figure out under what conditions it fails and how to rectify that. But I have stressed upon this point that the degree of freedom calculation is a very generic calculation. That means for small change in dimensions, this formula is not going to fail, but it might fail for very special dimensions. Then in the lecture 7, we discussed about Grashof criteria, which is a very important and useful criterion for 4-bar chains. We have discussed various 4-bar chains, for example, 4R chains, 3R 1P chains, RRPP chains, and RPRP chains. And in all of these, I have demonstrated how we specialize or extend the basic Grashof criterion, which is usually for 4R chains. How do we extend it to various other 4-bar chains that we have discussed? Then in lecture 9, we looked at problems using the Grashof criterion, various kinds of calculations you can do and find out. For example, if you have two chains which work in tandem, then and if the Grashof criterion is satisfied for one and not for the other, then you have to do a detailed analysis whether we really can have a fully rotating crank. As you know, the Grashof criteria tells you whether there can be a crank. That means a link which can rotate completely with respect to all other links. So presence of crank is tested by using Grashof criterion. Then we looked at, we started with displacement analysis in week 3. Displacement analysis gives you the output, let's say output angle or output throw of a chain given the input or the reverse. So we have discussed this forward kinematics problem and the reverse or inverse kinematics problem. And we have looked at 4R chains, 3R 1P chains, 2 types, etc. So we have looked at this displacement analysis with various examples. And we finished week 3 by looking at 2 very important steering mechanisms. The Ackermann steering mechanism, which is mostly used. So this Ackermann uses a 4R kinematic chain. So we have looked at steering mechanisms. And the second thing was the Davis steering mechanism. We have looked at the Ackermann and the Davis steering mechanism. And we have discussed how this Davis steering mechanism satisfies the steering condition. We have looked at the steering conditions we have derived and looked at the steering conditions. What we require is for front 2 wheels, the axis of the front 2 wheels must pass through a single point on the extended axis of the rear 2 wheels. This is the steering condition, and this ensures that slippage at the wheels is minimized. So that was our requirement, steering requirement, and that we have discussed. We are into week 4. I think we are finishing week 4. You have seen the displacement analysis of robots. So in 3 parts. So we discussed open chain and closed chain robotic mechanisms. So what are known as parallel manipulators. And then towards the end of this week, the 4th week, we have started with the velocity analysis. First, I have discussed about the geometric velocity analysis, and then how this velocity analysis is used to find out input-output velocity relations that we are going to discuss in subsequent weeks. I hope this has kind of, I mean, I hope you are able to go through these lectures smoothly. able to understand, and you are submitting the assignment. This is very important. Okay. Please, so that is more or less the overview of what we have discussed till now in this course. You are welcome to write onto the chat box. Please write in the chat box. Some of you have already written. Abhishek Kumar, okay, good morning. So this is the first class, yes. Mr. Sonkashkar, hello, good afternoon, yes, good afternoon. Mr. Sonkashkar, I think you might be a faculty somewhere. I would like to know the final exam question paper pattern. So these things will be clarified in the forum, but let me give you just a brief overview of the question paper. This will have a mix of various types of questions. There will be some which will be from the lectures, from the assignments, so very similar, and then there will be new kinds of questions, both numerical and multiple choice. So these things will be there in the final exam paper. So please go through the assignments and submit them. That will give you a very good idea of what you should expect. So you are a faculty somewhere, as you have written. Let me take one more question that has come in the Google Sheet, which one student, Mr. Saket Kumar. Mr. Saket Kumar has written that he is having some doubts in the degree of freedom calculation. In the degree of freedom calculation, there is not much to, do a calculation other than simple addition, multiplication, and proper counting. What is very important is to do a proper counting of number of links, of number of kinematic pairs, and especially if they are higher pairs, then you have to be careful about the degree of freedom of the higher pair. Typically, for example, a pin in a slot, it's a higher pair contact. This has 2 degrees of freedom. Why? Because one is the translational degree of freedom, the other is a rotational degree of freedom, and they are independent. Because a pin in a slot, it will not have a pure rolling contact. If it is mentioned specifically that there is pure rolling, then it has 1 degree of freedom. So these things you will have to be a little careful about. Then the counting of links is quite simple, but counting of joints or kinematic pairs. Suppose you have 2 links. For example, you have 2 links and they are connected by a kinematic pair, then you count it as 1. But suppose at a joint, at a kinematic pair, 3 links come and contact like this, suppose. So there are 3 links, they are joined by a single kinematic pair. Then you need to count them as 2. There are 2 kinematic pairs. So these things have to be kept in mind. Otherwise, beyond that, it's just the degree of freedom formula, and you have to remember the failure condition. Suppose this few things will develop as you solve problems. For example, you will be able to see, okay, if it's a parallelogram mechanism, immediately you will know that. So this example we have discussed also in the lecture. 2 parallelogram mechanisms in tandem, then it has 1 degree of freedom. But if you do a degree of freedom calculation, it will give you 0. And we have discussed exactly why. Right? So because of the very special dimensions, etc. So these things, the failure criteria conditions for the degree of freedom calculation, we have to kind of remember. So other than that, there is not much to worry about. This should work out. I mean, if you do a few exercises, it should work out fine. Yes, I think Pratay has forwarded this message from Mr. Saket Kumar that he is having doubt in degree of freedom calculation. So I have discussed it in detail. Okay, Mr. Sonkaskar, I hope I have been able to answer your question to some extent. Please write if you have faced some difficulty, maybe in assignments, maybe in following lectures. Please write in the chat box right now, and always give us a feedback of any difficulty that you face in the forum. We will try to answer as soon as possible. Okay, thank you. And there is one more thing in one of the lectures. Sometimes some error might have crept in, so please let us know so that we can keep track of that and we can advise students to be careful. So if you have found errors or slips, or sometimes some terms might get missed out, so please let us know so that we can disseminate this thing to everybody, so that people can do the calculation, cross check it, and they get the right thing. Okay, so please write in the chat box. We are waiting for your comments. If any feedback that you might have for this course. Okay, Mr. Saket Kumar, you have said that in week 3 assignment question number. So week 3, question number 2, I think it's a slider crank mechanism. Is that what it is? So basically, you will have this displacement analysis, and so I would in week 3 you have this displacement analysis of these mechanisms, constraint mechanisms, and so in displacement analysis, we have discussed this in detail in our lectures. And if you have very specific questions, I would suggest to bring it up in the forum so that we are able to exactly answer your question. And if required, we can also provide the outline, worked out outline for this. Week 3 assignment question 6. Let me just check if I have the same No, I have to. Mr. Saket Kumar, I will get back to you on this question because at present I am unable to connect with this week 3 assignment. How are we getting circle as a locus? So we'll try to answer this in the forum. I hope Mr. Pratyay Chakravarti he will keep track of this question. So your question is number 6 in week 3 and also question number 2 in week 3. Okay, so thank you, Mr. Saket Kumar. We will get back to you on the forum. So question number, so week 3, question number 2, and question number 6. So any other comments or questions or doubts that you might have, please write. Okay, Mr. Sonkaskar, maybe because you are a faculty already, I would like to know what you are teaching. Maybe you are teaching kinematics, so I would be interested in knowing how this course is helping you. That would be very useful for us. If you can write something about how this course is helping you in your teaching, maybe, or whether it's serving some purpose for your students, so that would be a very welcome thing. Okay, I think Mr. Pratyay Chakravarti has answered to Mr. Saket Kumar some questions, but we'll also answer this in the forum. Okay, so Mr. Sonkaskar, you are teaching kinematics of machinery. So I hope this course is relevant because in many of these courses, kinematics of mechanisms or machines, many of these courses, or theory of machines, dynamics is also included. And in many of these courses, Dimensional synthesis is also included. Even here in IIT Kharagpur, we do teach dimensional synthesis in one of these courses. So kinematics of machines, we do teach even dimensional synthesis, which is not covered in this particular course, because that involves a lot of graphical techniques, etc. And we also good. I hope you are learning. Yes, you have written that you are learning new things, maybe slightly new in some new ways. We want to present the things rather than what is usually presented in textbooks. Though we are not discussing dynamics, but we will discuss force analysis. So this is equilibrating forces. So input output force relation, like we have input output velocity relation in a mechanism, we will also discuss input output force, how much force will get transmitted, whether force will get amplified or diminished. So these things we will analyze, and we will show how certain mechanisms based tools, they can produce immense amount of force. That is what will be covered in the later lectures. Okay. Okay, so Mr. Sonkaskar, you have said that particularly we do not have robotic linkage in our syllabus. Okay, so here we are discussing planar robotic chains and closed loop or parallel robotic mechanisms as well. But everything is in planar domain. We have not gone to 3 dimensions in this course. Okay, Rimjim Kumari, you say C++. I didn't get your question though. Okay, then Mr. Saket Kumar has said, which type of steering mechanism is generally used in vehicles? So in vehicles, most of the time this Ackermann steering mechanism is used. The reason is Ackermann uses the 4R chain, 4R kinematic chain. And this Davis steering mechanism has that RPRP chain. Now, whenever you have a prismatic pair, first, it is difficult to manufacture. It is also very difficult to maintain. But then Davis has this advantage that it gives exact steering condition. But still, I mean, this prismatic pair, manufacturing a prismatic pair, maintaining it without having play, etc., or getting jammed. So maintaining that is very, very difficult. On the other hand, this Ackermann steering mechanism has only revolute pairs, and that makes it very robust. Now, in the cars or wherever this Ackermann is used, there is another additional part which is not discussed. So what is done is, when the steering rod comes to the mechanism, it actually the coupler that shifts in. There is something called a rack, and on that the coupler is actually directly connected to the steering wheel through an intermediate portion, and there is another part in that which allows the coupler, because see, when this takes a turn, the whole coupler actually rotates also. It's not just pure translation, so it rotates also. So to take care of this additional rotation, so there is an intermediate part which actually translates, and the steering wheel, so that is the rack, and the steering wheel which we hold and which we turn, that transmits a translatory motion to a rack, and this rack then transmits this motion to the coupler. So is a slightly more complicated thing, but overall, I mean the mechanism part, I mean, as far as the kinematics is concerned, so that is the Ackermann steering wheel mechanism. But you can have a look. There are more details in that steering mechanism. Once again, the C++, Ranjan Kumar, you are saying C++, does it mean that you want to code in C++? I would also suggest, though we do not discuss explicitly programming, but I will suggest students and also teachers to see that so the students should try to do some programming with this. Especially, I have in these lectures, I have always tried to tell how angles are determined once tangent of that angle is known. We have always tried to find out tangent of an angle, and the reason is that with tangent there are special routines in all programming languages, in MATLAB, in Mathematica, which, so you have this tangent inverse, which is called a tan 2 function. So how to use a tan 2 function to get the quadrant right? So this is a very important part. Otherwise, you see the mechanism, you might expect the mechanism to look like something, but when you draw it in a computer, it might just look something else because you got the quadrant wrong. It's a recommendation that you should try to also program and check whether your program is able to correctly determine the quadrant, and a tan 2 function will give you that facility. So using a tan 2, you can find out the correct quadrant. Otherwise, sometimes, especially near the dead center configurations, things might go in the wrong way. So a little bit of programming will be very useful in this course. Okay, Brajesh Saini, we are asking which simulator we can use to simulate manipulators. Now, there are various programs like Adams. Also, I mean, Adams, of course, does a dynamic calculation, but you can always do a kinematic simulation on that. There is another program called Working Model, in which you can do all these things, or even SolidWorks. It allows you to simulate mechanism, but you can always try to write your own code. For example, in MATLAB, or even in Python, for example. Nowadays, Python is very popular with students. So you can try to write possibly codes in Python, use graphics. But MATLAB is in that way a very good platform because it has the inbuilt functions available to you. All the inbuilt functions are available to you, and you can do not just drawing the configuration of the mechanism, you can do animation as well. You can do animation as well. And particularly in these times when things are under lockdown, it would be a very nice thing if the students can write their own animator in MATLAB, for example, and get a feel of the mechanism. So that would be very interesting as a term project in a course, for example. So for simulation, etc., I think MATLAB would be a very good platform where you can do the calculations, and also you can use its graphics to simulate or animate the mechanism. Okay, okay, thank you, Mr. Brijesh Saini, for being with us, for asking the question. Thank you, all of you. I would wait for a little more, a few more minutes maybe, and if you have further comments or questions, please post. We will get back with some of the questions that we could not answer here in the forum. And okay, there is a new question coming up. Mr. Brajesh Saini, I want to ask one more question. Which book I can refer to practice kinematics of manipulators? Uh, for kinematics of robotic manipulators, uh, there is a if you want to go to full 3D, I mean manipulators, and you want to analyze kinematics of general spatial robotic manipulators, uh, open chain serial manipulators, then the book of Fu, Gonzalez, and Lee. It's the name of the book is Robotics by Fu, Gonzalez, and Lee. So that is a very good book for kinematics, and not just kinematics. It discusses dynamics, it discusses controls, it discusses sensing, uh, image processing. So various things are there in that book. So that book is a very good book for kinematics. And so that is from McGraw-Hill. So this is Robotics by Fu, Gonzalez, and Lee. There is another book by Craig, uh, Robotics by J.J. Craig. That's also a very good book. Only thing is, Craig's book uses a slightly different notation or definition of the Denavit-Hartenberg parameters, which you might know, which is used in analysis of robotic mechanisms. In fact, you will find this Denavit-Hartenberg parameters even in the book of Ghosh and Malik, kinematics book, and you will also find robotic mechanisms there in Ghosh and Malik's book. Robot kinematics is also discussed, and Denavit-Hartenberg parameters are discussed. So these 2-3 books you can refer to for robotic manipulators. Okay, Mr. Sonkaskar, you have asked, degree of freedom calculation formula is new for me. Also, would you be covering graphical and analytical method for velocity and acceleration of pole bar mechanisms, Fourier component of acceleration? Uh, so here in this course, we have used we have tried to use the analytical approach for determining velocity and acceleration, and directly using the input-output relations of the mechanism. So that is we have discussed mostly. I mean, graphical methods we have not discussed in this course because you see the difficulty with graphical methods is you will have I will have to have the camera. I mean, and do the graphical analysis there on paper. Otherwise, it becomes a little difficult to transmit ideas. Otherwise, analytically, because nowadays you will be doing computations in a computer, let's say, and to have these analytical tools handy, or I mean, learning analytical tools will be very, very useful. Only thing for synthesis, when we do mechanism synthesis, then we have to use graphical methods because the equations that we deal with are highly nonlinear, and actually they're transcendental. They use sine, cosine involved in that. And you have seen maybe in displacement analysis, for example, we have to solve this equation a sine theta plus b cos theta is c, and how much algebra we have to do. But when we do graphically, it's very straightforward. But then graphical constructions come with their own disadvantages, like accuracy, problems of accuracy, etc. And and I mean, because computers are so much available, computing power is so much available, nowadays we will be using mostly analytical tools to analyze mechanisms and to simulate. Graphical velocity or acceleration analysis and doing it graphically will not be so useful, I think. But yes, synthesis, you will have to the first iteration has to be done graphically. Later on, for fine tuning, you can use a computer, you can use the displacement relations and fine tune the link lengths that we do in synthesis. But in this, of course, in this course, we are not discussing synthesis. Okay, so to answer your question, Mr. Sonkhaskar, we will not be covering graphical methods for velocity acceleration, but we have analytical methods. Yes, actually, Mr. Sonkhaskar, you had earlier commented that some questions can be solved easily graphically. That's true, absolutely true. Doing it graphically, it's quite straightforward and easy. But then with that result can have error. And now, if I ask in a question paper in an exam, if I ask for graphical construction and you give answers, then we'll have to look at the procedure. Otherwise, it will be very difficult to know the accuracy to which you can actually achieve, the accuracy that you can achieve. Yes, yes, Mr. Saket Kumar, we will have more interactive sessions in this course. Okay, thank you, Mr. Bajaj Saini. Okay, Mr. Sonkhaskar, yes, sir, I agree with you. Thank you. So thank you. I think we have taken quite a few questions, and I hope I have been able to answer some which I have not been able to answer. We will try to post in the forum. So maybe we can stop unless you have further questions, maybe 1 or 2 minutes more. Okay, Mr. Nitin Pradesh has this question. What are the further courses that we can refer? I think he meant refer after this course. So what courses you can refer after this course? That was the question. Question by Mr. Nitin. Now it depends on what are your interests. Suppose you want to go into robotics, robotic analysis, dynamics, then you should take a specialized course in robotics that involves robot kinematics, dynamics, controls. So robotics is a boiling pot for many disciplines, not just mechanical. It's electronics, it's electrical. So if you have interest in robotics, for example, this kinematics is a very important part, and it's a very difficult part for a spatial robotic chain. And some of the books that I have mentioned that cover robot kinematics, robot dynamics, like this robotics book by Fu, Gonzalez, and Lee, you can refer to, you can get interested maybe in these. So beyond this, you can take a course in robotics. You can take a course on dynamics also. Right. So Mr. Bajaj Saini says, "Sir, I'm from ECE Electronics branch, so I don't know about different types of motors and actuators which we use in manipulators. From where can I learn these things?" Now, these are very specialized things. If you are talking of an industrial scale robot, then the actuator selection is a big task. Why is a big task? I'll tell you. Big, first of all, the robot kinematic, the kinematic chain that you will use for that robot is very important. How much load you want that robot to carry? So that will decide the kind of kinematic structure that you should have. For example, a normal serial robot, serial manipulator, it has, you see, it has, I mean, these joints, and these joints are powered by motors. And you cannot place two big motors at the distal part of the robot manipulator, because the weight of the motor itself will load the manipulator. Beyond that, it will have to take the load that you want it to take, do some work or something. Therefore, you'll have to keep the motors more towards the base, so that it doesn't load the robot as such. So you'll have to think about it innovatively. You'll have to either use a transmission shaft or some other mechanism to transmit. For example, there is a very important kinematic structure. It's known as the Asada robot, which uses a parallelogram linkage to transmit rotary motion from a motor which is at the base of the robot. And there is a parallelogram linkage, and that transmits the motion to the distal part. So the elbow maybe of the robot, you can think. So the robot structure is very important. And then beyond, I mean, after this, you will now size your motor. Now you will not get motors of all possible torque ratings or current ratings. So you will have to see how much load comes on the motor. For that, we will be discussing in this course how to calculate forces. So based on the force requirement, you can select motors which are available standard in the market. Select motors. You also have to select gearboxes, because I mean, you will not require a very high speed, maybe a low speed but high torque motor. So you will have to have a gearbox. Now that makes it heavy. So you understand why we always would like to have a motor more towards the base of a robot. So these are the things that we have to worry about in manipulators, and designing manipulators, in dynamics of manipulators, etc. And you can learn about them, not precisely about motors, actuators, but you can learn in general about dynamics from this book of Fu, Gonzalez, and Lee. But that will not possibly give you the various detailed motor specifications. That you have to see various manufacturers, their specifications of various motors from the manufacturer. Right. So Mr. Abhilash Vishwakarma has forwarded the message from Mr. Nitin, which I hope I have answered. Right. So I hope I have answered Mr. Bajesh Saini about this actuators and motors and actuators. So to get an idea overview of what kind of actuators, what kind of motors, you can look into this book Robotics by Fu, Gonzalez, and Lee. But detailed specifications, torque ratings, etc. For that, you will have to look into the manufacturer specifications. So I hope I have answered your question. Okay, so if I have answered, then maybe maybe we will stop here for today. We will have further live sessions in this course. So maybe you will have more to say, more to tell me about the course, more to tell about your experience with this course, how this is being useful for you, your students or others. So please let us know. If you have worked on certain project and where you have possibly used these ideas, then that also you please tell us. Okay, then I hope this has been a useful session for all of you. I have also got to know some of your concerns, your questions, which we'll try to answer also in the forum. Uh, I would also like to thank our NPTEL office members who have made this live session possible. So a big thanks to the TAs of the course, Mr. Abhilash Vishwakarma and Mr. Pratyay Chakraborty, uh, who have answered some of your questions in the forum, I'm sure, and who is helping us in with this course. And so I thank you all. So I think with that, we can close down this session. So thank you.